Good morning, everybody. Thanks very much for coming. To help my presentation and before I start, I would like to ask a few questions. So, to avoid the awkward silence, it would be great if you guys can answer. So, we're going to talk about waterproofing. So, roofing systems, waterproofing systems. When you guys think about waterproofing, is there any go-to solution, any go-to technology that is usually specified or recommended by you guys?
Yeah.
Which one?
Zypex and
Zapex. Okay, for concrete crystalline. Okay.
Yeah, membrane. It's not a Sika product, is it? It's
sticker product.
Sika products. Yeah. What type of technology? Like a membrane, like a bituminous hot applied membrane? Okay. Well, is there any other technology like polyurethane, polyurea, urethane products, methacrylates? Is there anything else that is the go-to solution, or mainly membranes and crystalline?
Yeah, for us, we've got that master mix, I think, is a smaller, not so much waterproof. I think it's just to fill in some of the hollows, but I think it probably acts as a waterproofing as well.
Mm-hmm. Okay, very good. So, and when it comes to these technologies, for example, the membranes, is there any particular issue that you guys see happening on projects? Are you happy with the overall result of the current waterproofing systems that you are specifying?
Yes, yeah, we've had no issues.
Okay. And what's the type of warranty that you have from a system like that here in New Zealand? Like a 5-year, a 15, a 30-year? What's the?
Yeah, I think that warranties again. It might maybe
15, something.
Yeah.
15?
That
Okay.
might be a bit more, yeah.
Okay, very good. Well, thank you very much for sharing this information. I'm going to explain briefly about the technology that John was talking about earlier. A scientist back in 1975, he thought if you have a cut on your skin, you don't have to do anything and your skin will self-heal. With that, he thought, well, the main reason why we have issues with concrete is because concrete cracks. If you're able to do something that's going to help concrete to seal cracks, water will no longer penetrate through the cracks, and you're going to avoid the premature deterioration of the concrete. You're not going to have corrosion, you're not going to have freeze-thaw issues, you're not going to have carbonation. A lot of the issues that lead to the premature deterioration of the concrete, they're no longer going to happen because water is not penetrating. So what these scientists did was he put together a combination of enzymes, that these enzymes, they work in the concrete to waterproof the concrete. So this technology is a spray applied product that penetrates about 2 centimeters, 2 fingers inside the concrete, and all the reaction happens inside the concrete. So these enzymes, they penetrate in the concrete. After that, we use water to activate the enzymes. And in this case, it doesn't matter if the concrete is 28 days, 28 years, or 50 years. So it doesn't matter, different from a crystalline, for example, that you usually apply crystalline when you're pouring the concrete as an admixture. So this technology works differently, and these enzymes, they penetrate in the concrete, react with the concrete, and give the concrete the ability to seal cracks. What's very interesting is that these enzymes, they remain reactive inside the concrete for the service life of the structure. In other words, if you apply the product today, and then 5 years from now, there's a new crack in the structure, and this new crack might be an earthquake or something or something else that happened. What's going to happen is that these enzymes, they are inside the concrete. When water hits the concrete, the enzymes expand inside the concrete, sealing any new crack that happened. So the main reason why this technology lasts the service life of the structure is because every time that rains, water from rain is enough to reactivate these enzymes to be able to seal new cracks in the concrete. I'm going to show you guys the chemical reaction that happens inside the concrete. So, yeah, we can do in let's do 2 sides. Yeah. So I'm going to show here, and we can show on the other side. So this is the liquid with the enzymes. It's a clear liquid that we spray to the concrete. Let me do it here as well. And what's going to happen is after we spray the product in the concrete, the material is going to start penetrating the concrete, as I mentioned, 2 fingers, 2 centimeters inside the concrete. And after that, we spray water. What you guys are going to see here, let's go closer because I think it's going to be easier to see. What you guys are going to see here is a white gel forming immediately. So this is exactly what's going to happen inside the concrete. And this gel is going to be able to seal all the cracks, capillaries of the concrete. As you guys have seen, this reaction happens immediately. So what's very interesting is that sometimes when you have a crack in the concrete, as this gel is expanding inside the concrete, water will no longer penetrate. One of the main advantages of this technology is that all the reactions happening inside the concrete. So you don't need to use any type of protection screed. So this product can be exposed. So you have the concrete. The traditional system, you're going to have the concrete. On the surface, you're going to have hot apply membrane, something like that. And then after that, you have the protection screed, right? So this is the traditional way. In this case, you have the concrete. When you spray the product, this membrane is inside the concrete. So it doesn't matter what happens on the surface, that's not going to damage the waterproofing because the waterproofing is inside. So you're able to remove 3-4 centimeters of protection screed from the project because that's not going to be used to waterproof the concrete. Another big benefit of the technology is that it can be applied as soon as 28 days. So what we see a lot of projects doing, as soon as they are building the structure, they waterproof the concrete when they're still building the structure. So usually waterproofing is done on the later stages of construction. And on this way, you can anticipate the waterproofing. You can do that on the early stages. And one thing that this technology is going to be protecting the concrete earlier. So a lot of the other services that they would come later, you can anticipate that. So a lot of times only changing the time where we do the waterproofing instead of doing the later stages on construction. When we change to doing the earlier stages, you're already saving a lot of time on the projects. The other thing that's important is when you have a membrane system, a lot of times when you have the membrane, you might have a leaking here, but water is penetrating underneath the membrane and is leaking here, but the water is penetrating 20 meters away. I'm pretty sure you all have seen that before. One of the challenges that when you have to fix the leaking of a membrane, you have to figure out where water is penetrating. With this system, if you have a problem, if it's leaking here, the issue is exactly on top. So it's extremely easy to find the problem and fix the problem. And a lot of times fixing the problem is just respraying a little bit more material on the surface. So what's important to understand is that this product is part of a system. This technology is part of a system. And on the system, you have other materials, for example, sealant that are polyurethane-based, other materials, expansion joints, to make sure that you're going to have a watertight structure when your project is complete. This product can be applied on any type of concrete structure. So the requirements is that we need 25 MPa concrete, 28 days, clean and dry. That's all. So it doesn't matter if you're doing a water tank, a wastewater treatment plant, a bridge, any type of concrete structure that's going to need waterproofing. This technology can be applied, and all the reactions are going to happen inside the concrete. And you don't need, as I mentioned, any type of protection. Is there any type of structures that you guys are doing or are designing that you're concerned about the waterproofing? All of them or none of them?
Now, my main question is what about a car parking deck where you've got suspended and dynamic lights, like rolling lights?
Sure.
And movement going on between units?
Yeah, that's a good question. And one of the main challenges that a lot of times when we're explaining about the technology, Some clients, they compare with the crystalline, like you mentioned, Zypex. The crystalline technology is rigid. What's very interesting about this enzyme waterproofing is that it's a flexible gel that works inside the concrete. So when you have a structure that you're going to have thermal stress or you're going to have dynamics that you need a flexible waterproofing, this technology is exactly a good solution for this type of structure. So it doesn't matter if you're doing a car park, a bridge, or any type of structure where you're going to have not only thermal stress but also movement. This technology is flexible, so it's going to work with the concrete. It's not going to break like a crystalline technology would, as it's a rigid technology. And on a car park example, it's interesting that as the material is pre-applied, the application is extremely fast. So usually you apply, the application rate is between 300 to 800 square meters per hour. So usually when we talk about waterproofing, the traditional systems, it might be 200 square meters per day per crew. In this case, we're talking about 300 to 800 square meters per hour per person. So it doesn't matter what's the size of the project. Usually it can be done on a very short period. One of the interesting things is that as these enzymes, they remain reactive inside the concrete. This is the main reason why our technology has such a long warranty when you compare with the traditional technologies. So it's virtually impossible for the chemistry of a membrane waterproofing to be able to last 50 years, because the chemistry of a membrane is not going to last 50 years. But the chemistry of these enzymes, they work completely different. And a very interesting study that happened about 20 years ago, what they did was they got a core sample of the concrete where the product was applied 1 year earlier, and another core sample of the product of the concrete where the product was applied about 10, 20 years earlier. So what happened was when you compare a 20-year-old a concrete with where the product was applied 20 years ago, and another concrete the product was applied 1 year ago, what's extremely interesting is that on the 20-year, on the concrete where the material was applied 20 years before, you have way more gel inside. And the main reason why you have way more gel is because at times is going by, the material is penetrating deeper in the concrete. On top of that, you have rains during 20 years, it's not only 1 year. So we have more, you have more gel inside the concrete. And usually when I think about things that, I know that it's a hard concept to understand, because when you think about waterproofing, when we see the chart, usually the performance of any product is going down with time. So when you think about something that is getting better with time, we can think about wine that gets better with time. My wife absolutely gets better with time. And this technology is exactly like that. So it's getting better with time for two main reasons. One, every time it rains, water from rain is reactivating the product. So you have newer waterproofing every time that water hits the concrete. The second, this technology reacts with the free calcium on the concrete. So as the concrete is releasing the free calcium, this technology is, let's say, eating this free calcium to grow inside the concrete. So that's why, if you compare a project where the material was applied 20 years ago and another one that was applied 2 weeks ago, interesting enough, the product, the concrete where the material was applied 20 years before has way more gel because it had this dry, wet cycle for 20 years, and this is outstanding for the technology. What you're going to see when you have a small area, let's say a mock-up, you're applying 5 square meters, 10 square meters of product, you're going to realize that when you have a crack and you waterproof that crack, you waterproof the structure, when you go underneath, you are able to see that the leaking crack after the application is still going to be leaking, because this gel that we see here is forming inside the concrete. Depending on the width of the crack, the gel might be able to seal the crack in 6 hours, up to usually about 48 to 72 hours is when the large majority of the cracks in the concrete are completely dry. I can show you. We don't have pictures here, but I can show you some pictures on my phone of day one. You apply the product. You can go underneath the area. You can see the leaking crack, and then when you go back in the afternoon, some of the cracks they are already going to be dry, or if they were dripping, they're going to be dripping a little bit less. When you go back 48 hours later, the area is going to be, the crack is going to be drier, and then 72 hours later, usually 90% of the cracks are completely watertight. So it's very interesting that you're able to see the chemical reaction that's happening inside the concrete. You're able to see that very clearly because it was leaking before, now it's no longer leaking. So it's a very easy way to see that that happening. So when anyone here is working with infrastructure like bridges or structures like that? You are? No. Sorry? Like tunnels or bridges?
It's a sewage tank.
Okay, sewage tank. Okay. So let me talk a little bit about sewage tank. One of the this technology is completely green, is water-based. We have the potability certificate, NSF 61. We use that in the United States, in some other countries. So the technology is completely green for potable, for drinking potable water. So there's nothing, no problems on applying on pools or water tanks, nothing like that. When you have wastewater treatment plant, one of the concerns is the pH of the liquid that's there, and also the gas. You might have the H2S, right? So what's going to happen is that this technology is also protection against chemicals. So depending on the chemical that you have, if the pH is between 3.5 and 12, you don't have to do any other protection. Only the waterproofing with this technology is going to be able to waterproof and protect the concrete. Is there any other type of structures that you guys might be doing, like rooftops, or we talk already about car parks?
Basements?
Sorry?
Basements? Yes.
Basements? Yes. So the technology works great on below grade applications on basements. There's no problem. And usually, if it's a new construction, we have a new construction methodology where we use our crystalline admixture, like we were talking. Like ours, the technology of the crystalline is very similar to Zypex. We have our water stops as well, and we have the spray applied. So it's a system for below grade. Usually when you think about below grade, the main challenge is that a lot of times people reach out to us when it's already built and it's leaking. So no one, they don't do it before the issue. Yeah, exactly. So, and we are not a good solution for that because we need the dry area, the dry surface to apply our material. And usually when you have a leaking basement, it's leaking. So it's not a good, we are not a good fit for that. The crystalline technology would be a better fit for our leaking basement. Yeah. The projects that you guys are working, do you have any concern about the sustainability or the green aspect of that, or that's not a big concern here?
What about like Rotorua, when you've got sulfur? Have you had to deal with any of that?
With what? Sorry.
With sulfur?
Yeah. So usually there's no problem at all. So when we have very specific chemicals, we always talk with the technical department to try to understand the bigger issue. What we have done very successfully when we're doing fertilizer plants, for example, when we have the urea attack, this product gives a great chemical protection against urea and against other chemicals as well. So depending on the chemical, it's always good to know the concentration, because sometimes we're talking about a product that has a very low pH, but it's going to be diluted, and the final result is a pH of 4. So even though the product the chemical might have a pH of 1.5, when it's diluted, it's going to be 4 or 5. It's going to be a greater number. So that's not a concern.
What about hot water?
Sorry?
Hot water.
No problem at all. Yeah. So the only concern that we have about temperature is during the application. So during the application, the temperature should be between 5 degrees Celsius and 40 degrees Celsius. So if it's too cold, when we spray the product is going to freeze before it penetrates. And if it's too hot, the same thing is going to happen. So when we spray, the product evaporates before it penetrates. So it's not going to work. After the application, it doesn't matter the temperature. So on the last, as I mentioned, the technology has been around since 1975. So for virtually 50 years, we have projects in 75 countries. And it doesn't, and these projects, they are from very hot climates like Italy, South America, Florida, to very cold environments like New York, Scandinavia, areas that it's very, very cold. So after the application, it doesn't matter if it's a very hot environment or a very cold environment. The only concern, as the product is water-based, is during the application should be between 5 and 40 degrees Celsius.
Yeah, I just want to find out, I mean, we do a lot of applications of waterproofing systems like liquid membranes and bitumen and all of that. One question I've got is UV protection. Does it do, I mean, with everybody talks about the sun being here and it's a bit harsh over here, the UV.
Mm-hmm.
So how does that play compared to where it was designed to the New Zealand market?
Sure. So that's a good question. As all the technology is going to happen, all the reactions happening inside the concrete, it doesn't matter what happens on the surface. So UV rays are absolutely not a problem for the technology. That's not going to, let's say, kill the enzymes. The only thing that's going to kill the enzymes is prior to the application. If the product is on direct sunlight for a longer period of time, that's going to kill let's say, kill the enzymes before the application. But after we spray the product, is no longer a liquid like what we're seeing here. So it becomes this gel, and you are unable to remove that from the concrete. So what's interesting is that when you see a microphotography of the concrete, when we talk about subsurface membrane, sometimes it's hard to understand what is, a membrane inside the concrete. But you're clearly able to see like really a membrane filling all the voids, the cracks, the capillaries of the concrete. So you can see there's clearly a line, of this subsurface membrane inside the concrete. So it's really it's easy to see, this happening.
Okay. Does it affect the strength of the concrete?
So that's a good question. In the end of the day, it's not going to affect that. What's going to happen is that it's going to increase the hardness of the concrete. And usually the hardness of the concrete is 6 on the Mohs scale. And when this product is applied, it's going to change from 6 to 8 on the Mohs scale. So it's going to be a harder concrete. 8 is the equivalent of granite. The Mohs scale goes to 10, where 10 is diamond. So 6 is concrete and 8 is granite. So you're going to have a harder surface. And going back to the car park situation, when you have exposed concrete, when you apply this material, you're going to have a stronger, a harder concrete. So it's less susceptible to cracks or even other things that might happen to the concrete.
Yeah, sorry, just back to the basement. If you construct something like that and you fall back from anything or retaining walls or anything where it's in touch with the ground and chemicals and all of that, would that act as a moisture barrier as well then?
No. So that's what's going to happen with our technology is exactly the opposite. So what's very interesting is that when you see the gel like that, when there is water, the gel is going to swell. It's going to expand inside the concrete. When there's no water, when it's dry, the gel is going to shrink. Okay? The main reason why this is important is because when it's dry and the gel shrinks, any moisture that's trapped inside the concrete is going to be able to evaporate. So our technology has an 84% outgassing ability. So any moisture that was trapped there is going to be able to evaporate, so we are not trapping moisture. A lot of times, one of the issues that we have when you have the concrete and then you apply a membrane on top, not only membrane, but you mentioned about liquid applied waterproofing systems. You're very concerned about the moisture content of the concrete because you're trapping moisture inside. With this technology, it's exactly the opposite. So when you have moisture, when you have water, the gel is like that. And when you don't, it's like that. So water is going to be able to evaporate. The idea of the scientist, the way he explained to me was an easier way to understand is that when you're running, you're sweating, so water can go out. But when taking a shower, water's not going in. So that's exactly the way it works with the technology. So the outgassing ability, it's important because when you think about the main reasons why we have the premature deterioration of the concrete is because a lot of times water is involved. So if you're able to remove water from the equation, you're not going to have corrosion. It's impossible to have corrosion if you don't have water moisture. So in this case, two things are going to happen. When you apply the technology, you don't have new water going in because there's this protection, this two-finger protection inside the concrete that's not allowing water to penetrate. The second thing is that any moisture that was inside the concrete is going to be able to evaporate. So that's interesting because you're going to have, we're not able to, if you're applying the material on a 30-year-old structure that already has a lot of corrosion, the material is not going to make the corrosion disappear. So it's not unfortunately, it's not a magical product that's going to make the corrosion vanish. However, it's going to halt the reaction. So it's going to halt the corrosion. The way it is right now is going to be like that for the next 50 years. So it's not going to get better, but it's not going to get worse either. When it comes to liquid applied systems, what is the main technology that you're talking about? Is it like acrylic, polyurethane, cementitious, polyurethane? One part, two parts, okay. And what's the thickness? How many mils do you, or millimeters?
Well, you do about a mil. We use a product called Cowie product. We use a lot of that, but just on small areas and stuff. It's liquid membrane that you apply either with 2 coats or 3 coats, depending on what you want to get as a warranty and also as a thickness.
Okay.
Brush on.
And what's the type of warranty on a system like that?
15 years they do that.
Okay. Is there any VOC contents on the products that you're used to?
Yeah. That's
a high VOC?
No, it's a
low VOC. Okay. Is VOC a big topic in New Zealand or more? Yeah. Okay. In the United States, depends a lot on the area and the state. If you go to California, they want everything 0% VOC. Some other states, they want exactly the opposite. They want the more VOC, the better, apparently. So they're just kidding. So there's a big difference depending on the state. So that's why I'm asking. This technology, as I mentioned, is water-based. So has you guys can smell later. There's absolutely no smells. And it's interesting that some of the certifications that we have, the main challenge that we had, that we have for the last several years, is that when someone is thinking about our technology, there's not as lot for this type of technology. Usually, the technologies available are a liquid applied membrane, a liquid applied system, liquid applied waterproofing, membrane, crystalline, cementitious. So we have all these categories. But in our case, we are based on enzymes. We're not a silane siloxane. We're not a densifier. We're not a sealer. We're not a membrane, so a surface membrane. So we belong to a completely different category. And I know that sometimes that's challenging because there's not another technology that is like that. But some of the certifications that we have is the Miami-Dade certification. The Miami-Dade certification is one of the most strict certifications in the United States for a few reasons. One of them is because you have a lot of hurricanes in Florida. So they, in order to sell waterproofing products in Florida, they need to be fireproof, windproof, and depending on the situation, they need to be 0% VOCs. And our technology is the only product in the United States that has the Miami-Dade certification with 0.0% VOCs. So not only we are fireproof, we are windproof. And windproof is kind of funny because we are inside the concrete, so the you can test whatever wind speed you want, but I think the test is 300 miles, a very would be 500 kilometers per hour. So it's a very strong test, but for us it doesn't make any difference because we are inside the concrete. So what we have done is that as we understand that we don't belong to any of the traditional slots, any of the traditional technologies, we have done a marketing verification test with UL, Underwriters Laboratory, where they test specific what you state as that your product does. So in our case, they test the crack sealing ability, the future crack sealing ability, the freeze thaw, and the waterproofing performance. And they were able to state that whatever we state that our product is capable of doing, so sealing the 2 millimeter crack, 2 millimeters is the width of a car key. So this technology, if you have a concrete that you can put your car key inside the crack, this technology is able to seal a crack like that. It's a sizable crack. On top of that, if you have a future crack of 1 millimeter, 1.5 millimeter, we are able to seal that crack as well. So that's really, when you think about the 1.5 millimeter or a 2 millimeter crack, it's something that that's really disturbing. And sometimes when you have a wider crack, you might have way other problems and not only the waterproofing. But what's interesting is that we were able to get this certification that our marketing claims are correct. So from the crack sealing ability, the future crack sealing ability, the freeze thaw protection, and the waterproofing protection. One of the things that it's important to understand is that when we think about waterproofing systems, what they have done with this technology was, this was in, I think, Norway, back in the 90s. They test the product up to 400 meters of water pressure. So usually when you think about, the majority of the systems that you see around, they were tested for 25 meters of water pressure, 50 meters of water pressure. Ours was tested up to 400. And the only reason why they stopped at 400 was, as you guys can imagine, the concrete broke. So there was no leaking on the concrete, and up to 400 meters of water pressure, which is very impressive. One of the things that I wrote here to share with you guys, when a lot of times when we are talking about concrete waterproofing, it's interesting that a lot of the technologies, they have a system that works very well in theory inside the laboratory with no dirt at 20 degrees Celsius at the whole time. And it's a system that actually doesn't work well on a project because they have 7 layers, the moisture content should be XYZ, the temperature should be XYZ, otherwise, when you mix component A with component B, you have a 20-minute pot life to be able to apply the products. So it might be a technology that works extremely well inside the lab where you're able to control every single condition, but these are technologies that when you go to a job site, they are impossible to do. There are some systems that we see in the United States that have to apply 7 layers of waterproofing in order to be able to receive the 20-year warranty. And I'm thinking 7 layers, how do you control that? One of the challenges that happens every single time, between the 3rd and the 4th layer, it starts to rain. So now you're screwed because you have done 3 layers of a product, you're halfway through, you have to do the second half, you have to wait for the product to cure. So these are technologies that they might work very well. And some of these manufacturers, they mentioned about the elongation. So they get their product and they do like that, 800% elongation. And I'm thinking, if the building needs 800% elongation, that's a big problem. So that should not be the main marketing for these technologies. So what I think is the main benefit of this technology is the easy for the contractor not to screw up the application on a project. When we think about, I understand that many of you are architects and specifiers. When you are recommending a technology, we all know that there are a large number of waterproofing products around. You guys can recommend any given product, but you guys have only one reputation. So you guys are always very concerned about what technology you're going to recommend because you have only one reputation. So the main benefit that I see with this technology is that time after time, our technology is less expensive than the traditional. So I don't know how much the traditional system costs here, but let's say it costs 200. Ours is about 10% less expensive. So whatever number it is, usually our product is about 10% less expensive than the traditional systems. The downtime, the contractor is able to do any project if the traditional system would be 3 months to complete the project, with this technology would be 3 weeks. So you're able to complete the project on a way shorter time frame. In addition to that, we usually have the longer warranties on the market. And what's very different from what we offer to what other waterproofing manufacturers offer is that we only work with certified contractors. So we know exactly who is applying the material, and they have been trained by us to make sure that they know what they're doing. If there is a leaking on the project, usually what happens is there's a finger pointing between the manufacturer, the concrete waterproofing, the general contractor. There's a finger pointing between all of them, and the client that's paying the bill has a leaking project. So the contractor is saying that the problem is with the material that's not performing. The manufacturer is stating that the contractor didn't do the project, didn't do the application as they should. This is what we see in other markets. Is this the reality in New Zealand as well? Yep. Okay, so the finger pointing is something that doesn't happen with us for a simple fact that every single project that we do is certified by us. So if there's a leaking, there's one person that you guys have to reach out, that is Alchemco. So it's not the manufacturer talking with the contractor, there's a finger pointing, because in the end of the day, if the project is leaking, the goal is to fix the problem and not necessarily to discuss what was, who caused the problem. And this is, for us, the biggest challenge, because we have to train and certify each one of the contractors in which one of the cities to make sure that they are doing the application properly. So when I think about an architect and a specifier recommending a technology, what I think is very interesting about this technology is first, it has been around for 50 years. So it's not a technology that Mario and John put together last week in our basement, and now we are here talking with you guys. So it has been around for 50 years. We have different tests from dozens of countries. We have a lot of certifications and awards for most innovative technology. There's no other enzyme-based waterproofing in the world. So this is the only technology that is enzyme-based with this capability of sealing new cracks, sealing existing cracks. There's no other technology that is able to do that with the 2 millimeter existing cracks, 1.5 millimeter future cracks. There are no other technologies with these capabilities. So when you think about a technology that has 20, 30, 50-year warranties, has been around for 50 years, if there is a problem, it's extremely easy to fix the problem. As I mentioned, if it's leaking here, the problem is here. You don't have to waste time and money trying to figure out where the water is penetrating to try to fix the issue. It's extremely inexpensive to fix any type of problem. So that being said, in addition to that, it works in virtually any type of environment. So from very hot climates to very cold climates, weather is not a problem for this technology. Questions?
One of the things I was going to say, so a lot of the time here at waterproofing, you've got to put the tapes over the buildings if you're doing balconies and stuff like that to waterproof them, which is a huge expense. With Techcrete, it can literally be put down because we need water. So part of the process is you put the Techcrete down and then you add water to get the enzyme to grow. So there's no need to encapsulate a building and have it wrapped up for all this time while they get it just to the right water content so they can roll out their coats. So cost-wise, in that alone, it is a saving, and obviously in the time.
Mm-hmm.
So it's one of the things I think about for projects.
Absolutely.
What do you do for expansion joints?
So we have our expansion joints that are part of the system. So when we talk about the warranty is on the entire system. In the entire system, you're going to have this technology that's going to be applied in, I would say, 95% of the area. The other 5% are the angle changes, where we use a sealant. I can show you the CAD details later, but we have the sealant, and then we have a polyurethane that will go about 10 centimeters tall, 10 centimeters on the floor, and 10 centimeters on the wall. Expansion joints, we have water stops. So we supply the entire system to make sure that you're going to have a watertight structure. Yeah.
So that goes down to the basement side of things, which I think I also mentioned. So if you're building a building, and rather than tank it, you could literally do the whole Alchemco system.
Absolutely.
All the type the outside, so then you're not worried about the diggers hitting the wall because the membrane's in the tilt panel. So that's where so if you're doing a basement, you've waterproofed it from the outside on a new build, obviously, without having to do all the other type of tanking.
Absolutely. Yeah. And a good point here is that a lot of times when we are talking about a concrete structure, it doesn't matter if it's a house or if it's a water tank, a wastewater treatment plant, a bridge. These structures, they need to last a very long time. When we think about infrastructure, this is the most expensive asset that any country has is its own infrastructure. This technology helps the concrete from that infrastructure to last an additional 50 years, 100 years. So when we think about the additional cost to use this type of technology to protect the infrastructure, there's a big sustainability aspect because you don't have to rebuild that structure 20 years from now, because that structure is going to last another 50 years, another 100 years.
So when you were just referring to tilt slab construction, would you put the additive in at the concrete plant while the slab?
Yes.
Or apply it on site?
Both. So our experience that if we're able to add the mixture on site is better because we know for sure that the mixture is there. When you go to the plant, yeah, it's there. It is, yeah. And the guy's on TikTok, So the best way for us is to do it, before when the truck arrives on the project, we add that mixture, and our add mixture is not going to change this lump. It's not going to do any difference to the concrete. So we just add there. But we can add both ways, on the plant or on the truck.
And then you put the Techcrete, so that would be on the wall.
In the wall, yeah.
And then the Techcrete would be applied after the 28 days on the outside.
Correct.
Yeah.
Sorry, with curing your concrete on site, are you particular about the 28 days and how you cure it?
So wet cure is always the best option. And for our product to penetrate, if you want to use chemical curing compounds, it should be a chemical curing compound that's going to vanish within 20. Usually what we see is 56 days. So in about 2 months, it's going to be completely gone. Wet cure is always the preferred method. And one of the things that is interesting is that this technology, as it works inside the concrete, you're able to remove steps of the application. So for example, we're talking about, when we think about a basement, a below grade construction, a lot of times you're going to have, or even planters as well, you're going to have a protection board to protect the waterproofing. The main issue that we see is that sometimes the waterproofing is properly done, so there's no mistakes there. But when they're putting the protection board, the protection board is going to damage the waterproofing when they are installing the protection board. So with this technology is inside the concrete. So you no longer need the protection board. When you're doing a planter, for example, you don't need any anti-roots type of protection because this technology is inside the concrete. So a lot of times when you think about the waterproofing with this methodology, you're able to remove steps and remove other products that you would need on the traditional systems. But with this system, you're able to remove this item because it's no longer needed. And protection board is a good example because you don't need to do you don't need to use them.
With regards to certification, if the contractor mixes things up like gets different expansion joint from another company, gets another admixture from another company, and your company, would you still certify that?
Yes. So what happens is that if you're using the expansion joint from somebody else, on the warranty is going to be everything but the expansion joint. Okay, so that's easy. If you're doing, we always recommend using our crystalline mixture, but if you mentioned Zypex earlier, if you're already using Zypex, our technology works extremely well with crystalline technology. So there's no problem at all of applying our product, our spray applied, if you already applied crystalline from any manufacturer. The advantage of using our crystalline is that when you use both, you use our crystalline and our spray applied, we give even a longer warranty than the traditional. And if you use only if you use Zypex, for example, you only have the spray applied technology, spray applied warranty, and not the system warranty. Yeah.
I think it's important also to understand that this is a single one-time application for the life of the concrete structure. So traditional waterproofing systems will require maintenance from time to time, particularly grinding for removal, reapplication, if there's mechanical damage or malicious damage or environmental damage. All of those byproducts of removing existing failed coatings end up in landfills and ultimately back into the environment, whereas our product is, because it's a single applied application and it's within the concrete for the life of the structure, has no detrimental effects to the environment. And it, as far as I understand, Mario can also confirm that at the end of the desired life of the structure, the concrete can be recycled.
Yep.
With no
Exactly.
environmental
Yep.
detriments.
Yeah.
I think it's really important for both human health but also environmental health. So it ticks all the boxes.
Absolutely. When you think about traditional waterproofing, if you want to recycle the concrete, you have to remove the waterproofing before you recycle the concrete, and that doesn't happen with this technology. So if you have to recycle concrete, there's nothing to be removed, so we can just recycle concrete. When it comes to the environmental aspect, the technology is extremely concentrated. So to give a simple comparison, we were doing a project in Florida that was, I think was about 20,000 square meters. And the client, with the traditional system, they would need 84 pallets of material. With our product, they need 5 pallets. So even though that's a my main point about 84 pallets of product, that is, a container is, you're able to fit 20 pallets. So we're talking about 4 containers of product, 4 truckloads, compared to 5 pallets. The main difference here is that it's fewer products to transport inside the project. It's easier for the distributor to ship the materials, easier for to manage receiving the materials on the project. So this technology being extremely concentrated brings a lot of advantages that they're never going to be on a PowerPoint presentation, but whoever is on the everyday project, managing the project, it's way easier to manage receiving 5 pallets for a project than 84 pallets for a project.
Question about your curing time with a lot of the precast concrete the 15 PA if you're doing infrastructure stuff. Do they still have to wait for the 28 days curing, or because they quite often have quite a high turnover with that if they're done in a factory and they apply it early, does it still work?
So you absolutely can, and we have done as early as 7 days. If it's 14 days, I would say that 80% of the times we allow applying within 14 days. If any documents that we have is going to be written 28. If for one specific reason you need less than 28, then that's a conversation that the technical department needs to have to understand the specific needs of the project and to make sure that if our product is applied that early, if the technology is going to be able to penetrate. Because the main issue is that sometimes if you apply too early, there are no voids yet for no capillaries for the product to penetrate. So the product is not going to penetrate. And if the product doesn't penetrate, there's no reaction, nothing's happening. Yeah, just sitting on the surface. So that's why we wait 28 days. But
in order to migrate from the concrete.
correct. Yeah. But you can. We have done many projects within 14 days, and even less than 14 days. But that's a case by case situation.
So is that water content dependent?
Of the mix design?
So, I mean, is it the water content of the concrete that's the key issue?
When it's curing, yeah. Yes. So our concern is that if you're applying too early, the water content might be too high, and then it's not going to penetrate. Yeah. So and one of the questions is going to be, if you're doing that during the winter, that's a question that we always refer to the technical department, because if you're doing a project, for example, in Florida during the summer, I would say that very likely there's no problem at all of applying in 14 days. If you're doing a project here in the winter, I would say it may be better to wait 28. So I arrived this morning and I came from, it was 40 degrees when I left yesterday, Sunday, and then, here is 10 degrees. So it always depends on the, when you're doing, if it's summer, if it's winter, what type of structure. But so that's a question more for the technical department. Yeah.
Does the strength of the concrete have an effect on it? So say 40 MPa, 50?
Yeah, so the large majority of the projects that we do, they are between, I would say, 25 and 35. If we're doing infrastructure projects, sometimes it's a little bit higher. There are, depending on the structure that you're doing, we are not going to penetrate. So sometimes, for example, in Germany, you might have 80 MPa, 90 MPa. In a situation like that, you might apply our product, but our product is not going to be able to penetrate. So you don't have any advantage of applying our technology because you have such a high strength concrete that our product's not going to penetrate. But the majority of the projects that we do, they are between, I would say, 25 and 50 MPa. That's I would say probably 30 to 35 is 80% of our projects are between 30 and 35. The requirements, as I mentioned, the concrete needs to be it needs to be structural concrete, so we need rebars. I don't know if that's a big deal here in New Zealand, but some countries, when they're doing the protection screed and then the waterproofing failure, there's a failure in the waterproofing, and then they don't want to remove the protection screed, they want to apply our product on the protection screed to waterproof. And we give no warranty, that's not going to work. Our technology does not work like that. So if you have the concrete, the membrane, and then the protection screed, our recommendation, and there's a leaking, our recommendation is you have to remove, apply the product to the bare concrete, and then you can do whatever you want. You can paint, you can leave as bare concrete, you can put the protection screed on top, you can do whatever you want. But we need structural concrete, at least 25 MPa.
So you're saying if you've got a flat concrete surface, you put that on first and then you'll screed. If you have to.
Correct. Yes, correct. Yeah.
You're in a perfect world, you'd form the screen in form the falls in the concrete, which saves
It costs
a lot of time.
Yeah.
And then you've got concrete because screens.
Yeah, that'd be the best. Yeah.
They always delaminate through time. So the best way of doing it, if you can form the falls on the decks. There's so many balconies around that would benefit from that. Without screens, I know we put them on and we've had issues.
a very important aspect is that when we think about the traditional waterproofing, the first thing that we do is we do all the patches, all the repairs, and then we apply the waterproofing. In our case, it's exactly the opposite. So if there's any honeycombing, so before we need to apply the technology to the structural concrete. So we don't do any patches before the structural concrete is waterproof. And usually what we do is after all the waterproofing is done, before the patching, we do a water test because we want to make sure that the concrete is waterproof. And then if the concrete is waterproof, we're good to go, and then we can do whatever patching we need to be done. So during the water test, you might be able to see rebars and everything because the patches were not done yet. And our product is applied to the structural concrete before the repairs.
And it'll work with reinforcing the fibres. As Austin down there, what's your fibre? What do you call your concrete?
Oh, yeah, it won't make any difference.
It won't make a difference.
No, just right, if my water tank is leaking, do I have to empty it and apply your material on the inside?
Yes. We always, the preferred method is on the positive side. Yeah, positive side. So you're able to do on the negative side, but usually as we are concerned about corrosion, if you're applying on the negative side, water might no longer be leaking because you waterproof, but corrosion is still happening because water is penetrating the concrete. So we always recommend applying on the positive side. Yeah. Is that an existing water tank that has a failure waterproofing? The example that you were.
Just putting it out there.
Okay.
Particular tank.
No.
Situation that
Yeah.
comes up. Yeah.
Sure. So what happens is that the technology needs to be applied to clean structural concrete. So a lot of times when we are doing a water tank, for example, we need to make sure that we remove everything. We have the bare concrete, and then we spray the product. So we have to remove any coating, any cementitious waterproofing. If it's a car park, any oil stains, we need to remove everything to be able to apply the product.
What about if you could maybe just talk to the ability of the product to arrest decay in concrete, so particularly in like sewer pipes and stuff, where there's been hydrogen sulfide attack.
Yep.
What would the methodology be in terms of removing existing decay and then applying the product to arrest any further decay and then thereby saving the infrastructure?
Absolutely. So what's important is the technology always needs to be applied to clean structural concrete. So in the case of, if you have a pipe, a concrete pipe or something like that, you need to do the preparation is very similar than any other waterproofing system that you might apply. So if you were applying a coating or a cementitious or acrylic, the prep itself is very similar. So we need to make sure that we clean that very well, and then we just spray the material. We have done in Utah, in the United States, a lot of concrete pipes, and the issue a lot of times is that it's a very, depending on the application, a very small area to work. And the other concern is that depending on the technology that's being applied with a higher VOC, the strong smells are hard for the laborers the workers that are applying the product. So this technology having no smells is a big advantage for the worker who is applying the material. And as we discussed, is going to give not only the waterproofing protection, the waterproofing benefit, but also the chemical protection. So we have a lot of clients that they use the technology to protect from chemicals. So we do, for example, salt storage tanks. I mentioned about fertilizer plants. So there are a lot of areas that the main concern is not necessarily the leaking, for example. If you're doing a pool or a water tank, a wastewater treatment plant, a rooftop, then you're more concerned about the waterproofing aspect because you need a watertight structure than any type of chemical protection. But For example, we do a lot of infrastructure. We do a lot of bridges, railroads, and all these areas, they need to be waterproof. They need to be protected to make sure that water is not going to lead to the, is not going to is not going to have corrosion of the rebars if you don't waterproof. And what's I moved to the United States about 9 years ago, and when I was having meetings with a lot of the Department of Transportation engineers, a lot of the bridge engineers, my number one question was, right, what are you doing to protect your structure? So I'm going to ask you guys, what do you guys think that was the majority of the answers that I heard in the United States, the country with a $30 trillion GDP, what do you think that they were doing to protect their bridges?
Nothing.
Nothing. So, and then I was trying to understand, okay, what do you mean by nothing? No, we're not doing nothing. So, because it's concrete, it's strong, nothing's going to happen. And it's interesting because when you compare with the way Europe treats their bridges, Europe treats their bridges exactly like in the United States they treat a rooftop. So they have a completely waterproofing system for a bridge because they understand that this is the most expensive asset that we're building. And by the way, these needs to last 100 years, 200 years. So in the United States, I would say 50% of the states, they do nothing, 50%. As you go north, that usually tends to be a little bit different because they are using a lot of de-icing agents, a lot of salts, so they're more concerned about corrosion. But that's, I thought that, well, it's going to be a no-brainer, they're doing something. But no, sometimes you might be talking with an engineer from Iowa, and they use, I don't know, 50 pounds of de-icing agents per square meter, and you ask them, okay, what are you doing to protect, from the de-icing agents? So, well, we are, after the winter, we water the area to remove the, and this goes, of course, to the creek. But they're not doing anything at all to protect, which is very concerning. So when I understood that they were not doing anything, I understood, okay, so I have to change my approach. My approach needs to be, I need to educate them why they need to waterproof their bridges, why they need to waterproof their railroads, because until that time they were. It's always a long shot, because if they're not doing anything, it's free and it's already done. So if you're trying to convince them, why don't you, close this bridge to waterproof the bridge? It's going to cost something, and it's going to take time. All right, questions. Have you guys? Is it the first time that you guys hear about the technology? Seems to be a good technology.
Yeah, is it sold solely as a H2S protection product, or so to say if you've got a wet well, you're not worried about water integrity, waterproofing, but it's it's got high H2S levels. It's not something you'd use for that.
For what type of situation?
Or H2S on concrete.
So we could use this material specifically for this type of protection.
Okay.
Yeah. So we're doing, for example, we do a lot of sewage plants, wastewater. I don't know how you call it here, but wastewater treatment plants, sewage plants. We do a lot of areas like that, from apartment buildings to. We're doing several now in the Philippines and India as well, in the United States, in South America. That we're doing a large one in Portugal as well. So it's there's no problem at all on with the chemicals.
And if it's when it's applied on a new structure for some reason under stresses and maybe some seismic stuff, and it develops some cracks over years, will it fill up to those 2 millimetre voids? Only it wouldn't sort of maybe offer some additional protection?
So the future crack is going to be up to 1.5 millimeters. But I'm going to share a story that happened a few years ago in Taiwan, that they had a car park and they apply our material to waterproof. Before the application, the area had a lot of leaking cracks and all of that. And then after the application, it was a completely watertight building. Great. And then a few years later, they had an earthquake. When they had the earthquake, and then they had rain, a lot of the cracks, they were leaking after the earthquake. What was very interesting, the testimony from the building owner, was that after a few days, only with water from rain, all the cracks were watertight. So in our warranty, as you can imagine, we don't say earthquake proof. So we don't have these, there's a disclaimer that, acts of God, we cannot give a warranty on an earthquake. But what's very interesting is that the testimony from this car park owner, that he had a watertight structure, he had a leaking structure. After the application of our product, it was watertight. They had the earthquake, and then it was leaking again, and then only with water from rain, this was enough to waterproof to reactivate the enzymes and waterproof the cracks. Yeah. But we don't, in our warranty, earthquakes are out. So, yeah.
Are you going to go through the brand certification process at all? It's like a New Zealand
So we're talking about the brands. So we're going to go on to master spec, but we're not sure. Though it's like feedback. I've spoken to a few contractors, and they said that brands is purely for the domestic market. So we probably can go with brands, but certainly the master spec is the first port of call. Really targeted towards the commercial side of things. But like if we were like for balconies and on apartments, then sure we would look at putting the brands into doing it on the brand certification for here and Australia. Now everyone wants to go to the pub.
Yep. All right. Yeah. Well, thank you very much. Yeah. Thank you for your time. Yeah. We're going to be here if you have any other questions. Yeah. Thank you.